Good morning, students. The last class we discussed the special integrals. Okay, special integrals. In special integrals, three types of question we have discussed. The first one is using standard result. The second one, coefficient of x square, some another constant. And the third one is numerator is a function. That may be the derivative of another function. And the fourth one is the denominator is of the form ax square plus bx plus c. Okay, that is a quadratic polynomial. The denominator is in the form ax square plus bx plus c. Okay, that is a quadratic polynomial. If the denominator is a quadratic polynomial, we have to convert into a perfect square. That method we have studied in 10th standard, method of completing the square. Do you remember? Okay, what are the steps? The first one, convert the coefficient of x square into unity. The coefficient of x square to unity, that is 1. And the second one, add and subtract half of the coefficient of x whole square. Which term? Half of the coefficient of x whole square. Okay, these are the two steps. The first step is convert the coefficient of x square unity. That means if the coefficient of x square is 9, take 9 outside. Coefficient of x square is 4, take 4 outside. Okay, that is by taking the coefficient of x square outside. And the second step is adding and subtracting half of the coefficient of x whole square. Do you remember? Okay, we can do some questions. Okay, the first one, 1 by root of x square plus 2x plus 2 integral 1 by root of x square plus 2x plus 2. Okay, this is very simple, but it is very important. Okay, then first we can change the polynomial x square plus 2x plus 2. What is the first step? Making the coefficient of x square unity. And here what is the coefficient of x square? It is already unity, no need of first step. And the second one, add and subtract half of the coefficient of x whole square. What is coefficient of x here? 2. How will you find half of 2? 1 by 2 into 2, 2 by 2. What is 2 by 2? 1. Then half of the coefficient of x is 1. But we have to add and subtract half of the coefficient of x whole square. What is 1 square? 1 itself. Okay. Then no need of first step, x square plus 2x. Write the first two steps, say 2 terms, x square, 2x. Then in next term, we are adding and subtracting half of the coefficient of x whole square. That here it is 1. Adding 1. Okay, by adding 1 the value will change. At the same time we have to subtract 1 and group the first three terms, then minus 1. Then don't forget to write the constant plus 2. Is it okay? What is the first step? Convert the coefficient of x square unity by taking the coefficient of x square outside. And the second step, add and subtract half of the coefficient of x whole square. Okay. Then what is x square plus 2x plus 1? The first three terms, grouping the first three terms, that is always a perfect square. Either it is of the form a plus b whole square or a minus b whole square. How will you find a and b? A is the square root of the first term, square root of x square, x. Here the middle sign plus, then we have to write plus. If it is minus, we can write minus. And b is the square root of the third term, square root of 1, 1. That is x plus 1 whole square. What is minus 1 plus 2? Minus 1 plus 2, that is plus 1. Okay, then we can write this question as integral 1 by root of x plus 1 whole square plus 1 is 1 square. Okay, do remember the result, that is of the form 1 by root of x square plus a square. What is 1 by root of x square plus a square? 1 by x square plus a square is 1 by a tan inverse x by a. But here root is there. If the denominator contains root, the result is in terms of log. You have studied, that is log mod x plus root of x square plus a square. Instead of x, here the variable is x plus 1 and a is 1, and we got the result log mod x. What is x? X plus 1 plus root of x square plus a square, that is x plus 1 whole square plus 1 square plus the integrating constant c. Is it okay? And the fourth type is if the denominator is of the form ax square plus bx plus c, that is a quadratic polynomial, then we have to convert into a perfect square by following two steps. Which are the two steps? Convert the coefficient of x square to unity by taking the coefficient of x square outside. And the second one, adding and subtracting the coefficient of x whole square. Is it okay? Yes. Then two more questions we can do. Then next one. Integral 1 by 9x square plus 6x plus 5 with respect to x. Okay, 9x square plus 6x plus 5. Then first we can convert the polynomial into perfect square. Then what is the coefficient of x square here? Yes, here the coefficient of x square is not 1, it is 9. Okay, take 9 outside and convert into perfect square. Okay, 9 outside means we have to divide throughout by 9. X square plus 6 by 9x plus 5 by 9. See, this 6 by 9 we can cancel. What is 6 by 9? Is cancel by 3, 2 by 3. Is it okay? 2 by 3. That is 9 into x square plus 2 by 3x plus 5 by 9. Then what is half of coefficient of x whole square? What is it? Half of coefficient of x is 2 by 3 whole square. 2 cancelled. 1 by 3 square is 1 by 9. Is it okay? Then add and subtract. That is 9 into x square plus 2 by 3x. Okay. Then here after two terms we have to add this plus 1 by 9 and group the first three terms. And similarly subtracting 1 by 9. Then the last term is 5 by 9. Okay? 9 into. And okay, I told you this must be a perfect square. Then the middle sign is plus and identity is a plus b whole square. We can find a by square root of the first term, x square x. Square root of 1 by 9, 1 by 3 whole square. Minus 1 by 9 plus 5 by 9. Yes, 4 by 9. 4 by 9. Or we can write 4 by 9 as 2 by 3 whole square. And this is x plus 1 by 3 whole square plus 2 by 3 square. Up to this much, is it okay? Then we can substitute. The question becomes 1 by 9 into x plus 1 by 3 whole square plus 2 by 3 whole square with respect to x. Okay, we can take the constant outside. 1 by 9 integral 1 by x plus 1 by 3 whole square plus 2 by 3 whole square with respect to x. Can we state the standard integral? It's 1 by x square plus a square. What is 1 by x square plus a square? Yeah, no square root. 1 by a tan inverse x by a. Instead of x, it is x plus 1 by 3 and the constant a 2 by 3. Don't forget this constant 1 by 9. 1 by a, 1 by 2 by 3. We can write 3 by 2. Tan inverse x plus 1 by 3 by 2 by 3 plus c. We can simplify. Okay, 1 by 9, 1 by 2 by 3 becomes 3 by 2. Tan inverse, cross multiplying, 3x plus 1 by 3 divided by 2 by 3 plus c. 3, 9 cancelled and here 3 cancelled. The answer is 1 by 6 tan inverse 3x plus 1 by 2 plus c. Is it clear the method? Okay, then this is the fourth type. The fourth type is the denominator is a quadratic polynomial. If the denominator is a quadratic polynomial, we have to convert into perfect square. Okay, by following two steps. Which are the two steps? Making the coefficient of x square 1 and add and subtract half of the coefficient of x whole square for converting into the standard result. Is it okay? Then we can do one negative question. The next question is integral 1 minus 4x minus x square dx. Okay, then take the polynomial. 1 minus 4x minus x square. Okay, see, we can convert into perfect square. First step, making the coefficient of x square unity. What is coefficient of x square here? Negative 1. Take negative 1 outside. We can write this as negative 1 plus 4x plus x square. Or in standard form, we can write this as negative of x square plus 4x minus 1. Is it okay? Yes. Then add and subtract half of the coefficient of x whole square. What is coefficient of x here? 4. Half of x, half of 4, 2. Then 2 square, again 4. That is adding x square plus 4x after 2 terms. Adding 4, then subtracting 4. Okay, is it okay? That is minus. Then can you say this identity? Yes, x square square root x plus 4 square root 2, x plus 2 whole square, minus 4 minus 1, minus 5. Okay, see, by substituting this result inside the integral, it is root of negative 1 into x plus 2 whole square minus 5. Instead of negative 1, if it is some other constant, we can take this constant outside from the radical. Okay, but if negative 1 is inside the radical, it is not a real number. You have studied root of negative 1, root of negative 2, root of negative 3, that is become a complex number. Okay, then note this point, if negative is there inside the radical, we have to simplify from here itself. That means we can multiply by negative sign. This is become negative x plus 2 whole square, negative into negative, positive 5. Okay, why? If negative is inside the radical, we cannot take it outside. It becomes a complex number. We can write this as 5 minus x plus 2 whole square. Is it clear? Okay, that is integral root of 5, we can write root 5 whole square minus x plus 2 whole square. Okay, what is the standard integral? Yes, the standard integral is root of a square minus x square. What is root of a square minus x square? X by 2 root of a square minus x square plus a square by 2 sine inverse x by a. Instead of x, here it is x plus 2 and a is root 5. Okay, the answer x by 2. X plus 2 by 2, x by 2, root of a square minus x square, root 5 square is 5. 5 minus x plus 2 whole square plus a square by 2, 5 by 2. Sine inverse x by a, that is x plus 2 by root 5 plus the constant c. Okay, then don't forget, you note this point. This is very, very important. If the negative 1, if the negative number is inside the radical, you have to simplify before by substituting. Okay, don't forget. If you have any doubt, please clear the doubt through WhatsApp or personally you can call. Okay. And this is the fourth type. Okay, the next type, the fifth type. 5 types questions are there, I told you. The fifth type is, if the numerator or if the integrand is of the form px plus q by ax square plus bx plus c, or px plus q by root of ax square plus bx plus c. Okay, not the two type. If the integrand is of the form px plus q by, numerator is a linear polynomial and denominator is a quadratic polynomial. Okay, numerator is in terms of x and denominator in terms of x square. Okay, and if the integrand is of the form linear by quadratic, px plus q by ax square plus bx plus c, then we have to convert the numerator px plus q as a into derivative of the quadratic polynomial, no need of taking the radical side, ax square plus bx plus c plus b, where a and b are constant. What is the method? If the integrand is of the form linear by quadratic, that is numerator in terms of x and denominator in terms of x square. If it is of this form px plus q by ax square plus bx plus c, or px plus q by root of ax square plus bx plus c, then convert the numerator in terms of a constant a into derivative of the quadratic polynomial denominator plus another constant b. Okay. See the fifth type. We can do one example. It is very simple. Okay. See x plus 2 by root of x square plus 2x plus 3. See, the numerator is in terms of x and denominator is a quadratic polynomial. Okay. Then first we have to convert the numerator as a into derivative of denominator plus b. That is x plus 2 equal to a into derivative of, okay, the denominator polynomial, no need of taking the radical, x square plus 2x plus 3 plus b. Now what is the derivative of x square? 2x. Derivative of 2x, 2 into 1. 2. Derivative of 3, 0. That is 2x plus 2 plus b. Changing the bracket, 2ax plus 2a plus b. Okay. Then for finding the constant a and b, we can equate the coefficient of x and the constant term. Okay, the coefficient of x here 2ax, coefficient of x here 2a. Here coefficient of x 1. That is 2a equal to 1, a equal to 1 by 2. And by equating the constant term that is independent of x, 2a plus b equal to 2. 2a plus b equal to 2. What is b? 2 minus 2a. What is a? 1 by 2. 2 cancel. 2 minus 1, 1. We got the value of a and b. Then now we can write the question or the numerator x plus 2 equal to a into 2x plus 2. That is 1 by 2 into 2x plus 2. Plus b, that is plus 1. Divided by the denominator. No change. Okay, we can write the question as a into derivative of denominator plus b divided by the same denominator with respect to x. And now the numerator contains two terms. What is the method? That is a basic rule of integration. If the numerator contains more than one term, we can split into two. That is half, it is a constant, take it outside. 2x plus 2 into root of x square plus 2x plus 3, the first integral, plus 1 by root of x square plus 2x plus 3. See the first one, in fifth type, the first term is always a standard result. That is either in the form f dash x by f of x. What is f dash x by f of x? Log mod f of x. Okay, or f dash x by root f of x. What is f dash x by root f of x? 2 root f of x. Okay, note that point. If in fifth type, the first integral is always in the form f dash x by f of x or f dash x by root f of x. And here which is of the form f dash x by root f of x. Okay, what is the result? 2 root f of x. And the second one, okay, that is the fourth type. Then for what is fourth type? As 1 by a quadratic polynomial. Okay, how will you simplify? As convert into a perfect square. Okay, change the coefficient of x square unity. Here it is already unity. Then add and subtract half of the coefficient of x whole square. Half of 2, 1, 1 square, 1. Adding 1, subtracting 1, it becomes x plus 1 whole square plus 2. And now the first one is f dash x by root f of x. Result 2 root f of x, where 2 cancel and f of x is x square plus 2x plus 3. And the second integral is of the form x plus 1 whole square plus root 2 whole square. 1 by root of x square plus a square. What is the result? Log mod x plus root of x square plus a square, where x is x plus 1 and a is root 2. Okay, and this is fifth type. We can do one more question. See the next one. Okay, integral x plus 3 by x square minus 2x plus 5 with respect to x. Okay, then first we can, this is fifth type, we have to convert the numerator in terms of a into derivative of denominator plus another constant b. Okay, then x plus 3, the numerator. We can write x plus 3 as a into derivative of denominator x square minus 2x plus 5 plus b. Derivative of x square 2x minus 2x minus 2, 5, 0. Then x plus 3 equal to a into 2x minus 2 plus b. How will you find the constant a and b? Yes, by equating the coefficient of x and the constant term. The coefficient of x is 2ax equal to 2a equal to 1, a equal to 1 by 2. And the constant term minus 2a plus b equal to 3, or b is 3 plus 2a. By substituting a 1 by 2, 3 plus 1, 4. Then we can write the question as half of a into derivative of denominator, half of 2x minus 2 plus 4 by the same denominator, x square minus 2x plus 5 with respect to x. And here the numerator contains two terms. We can split into two, half constant, 2x minus 2 by the denominator plus taking 4 outside, 1 by x square minus 2x plus 5. Okay, I told you the first term is either of the form f dash x by root f of x or f dash x by f of x. And clear, the first term is of the form f dash x by f of x here. What is f dash x by f of x? The result, log mod f of x. What is f of x? X square minus 2x plus 5. The first one is okay. And the second one is of the form, fourth type, 1 by quadratic. Okay, make into perfect square by changing the coefficient of x square unity and by adding and subtracting half of the coefficient of x whole square. Then x square minus 2x plus 5 we can write x square minus 2x. Okay, coefficient of x square is already 1 and half of the coefficient of x. Here coefficient of x minus 2. Okay, half is minus 1, square is 1, adding 1, subtracting 1. It becomes x minus 1. How it is minus? The middle sign is minus. X minus 1 whole square plus 4. Or we can write x minus 1 whole square plus 2 square. By substituting, the second integral becomes 4 into 1 by x square plus a square. What is 1 by x square plus a square? 1 by a tan inverse x by a, where a is 2 and x is x minus 1 and 2, 4 we can cancel. The result is 1 by 2 log mod x square minus 2x plus 5 plus 2 into tan inverse x minus 1 by 2 plus a. Okay, and this is about the special integral. Okay, and special integral exercise is very important. Okay, which contains 5 types of question. First 3 are simple and 4th and 5th type is important. It is not very difficult. The 4th one is the denominator is a quadratic polynomial and the 5th one is the integrand is linear by quadratic. Okay, you watch this video 2 or 3 times. Okay, and ask your doubt and do the similar question yourself. Okay, thank you.